To check for symmetry in a graph, we simply want to see if there's any spot we can imagine folding the graph to get it to line up with itself. For example, in this first graph here, I could imagine if I folded the graph along this dashed line, the graph would line up with itself. And so what we'd say is this graph shows x-axis symmetry, because the x-axis serves as our line of symmetry. We'll talk more about symmetry next week and what this has to do with the functions we're looking at. The graph right next to it, I can imagine folding along this vertical line to get the graph to line up with itself, so we'd say this graph shows y-axis symmetry. Moving to the third graph, there's not a vertical or horizontal way we can fold the graph. However, we can kind of imagine folding it along this line, or some people notice like the graph is sort of rotated to get it to line up with itself. Regardless of how you want to think of it, when a graph sort of looks like this, we would say it's symmetrical about the origin. It shows an origin sort of symmetry. All right? These bottom two, I don't think it's hard to see that this first graph on the bottom doesn't show any symmetry. There's nowhere you can fold it to get it to line up with itself, so we'd say there's none. Finally though, this graph, and this again is tricky for some people, there's no vertical or horizontal way to fold it. However, you can kind of imagine like rotating this graph around or folding it along sort of a diagonal line like that. Again, this graph, because of those characteristics, shows symmetry about the origin. So this graph is symmetrical about the origin.